Hey everybody, this is Jace again with ARM US, and once more joined by
Jon McBride of Autel Robotics.
That's right. So if you can't already tell, we're here actually in Warehouse, and we're looking at the Dragonfish models. And this has actually been something that we've wanted to do for a little while because we have the original Dragonfish, which is it's the middle ground, right?
Yeah. We call that the standard. So the standard
Dragonfish, which was the first, and you know it's been very successful in the field. But we have these two other models. We have the Light, we have the Pro, and really a lot of people are, what's the difference between the two? Is there an advantage of one over the other? What's the right fit for me?
Sure.
And that's kind of what we want to shed some light on today is, you know, starting with the original, which is, again, everybody's very familiar with. It's been very successful.
Yes. So yes, we have 30. So just real quick, it is the standard, referred to as the standard. The physical size, almost 8-foot wingspan. Flight time on perfect paper, 2 hours, but we usually get about a practical flight time about an hour and a half to an hour and 35 minutes. You know, that's
depending
realistic.
on the mission.
Depending on the mission, we happen to be here in Utah at 4,600 MSL, so that does have a factor and a bearing on that. You can also have high winds and things that are attributed to flight time. But overall, when we first came out with this one, there was two payloads available. One was the Z2 and the T3. So we had a optical zoom and a wide camera payload, and then we added a thermal payload to it.
Right.
Now that I have about 30 of these operating in the United States, so that's about how many we have so far in the United States, we've made this kind of a little bit better payload to incorporate our laser rangefinder. So this is the same optics as the T3. We have a 20 times optical up to 200 digital.
Right.
We have a 640 thermal, and then the wide camera for situational awareness and pop it back and forth.
Right.
But adding that laser rangefinder, really important on how the engineering came into play. When anytime we're flying a drone, and one of the kind of general ideas is like we want to know where something is. Fly the drone over the top of something, and you have to be directly over the top because that is a reported XY position. Right? Okay. But if you are at a distance away from something and shooting at something, that is a very complicated algorithm.
Right. Well, we need that hypotenuse, as it were. Harken back to your geometry high school days, right? But that's that extra piece of data that we need to locate that specific position.
So not that the T3 is not capable of giving us a great, you know, where it is, but we can increase our ability to find something if we're reporting that back to somebody. So if we find an area that we need to investigate for guys on the ground, they get an X and Y, we can be somewhere within plus or minus 10 to 15 meters, you know, plus or minus. So if you're looking for a person, that might not be bad, you know, hey, hello, hey. But if you're looking for something that may have been thrown out of a window and you caught it with the Dragonfish and they need to specifically go out there and find something that's this big, you could use the L22
Well, we're getting in
with the
striking
laser.
distance here. Which
now we're bringing that down to less than a meter.
Right.
You know, so that is the big one. Other things that we'd kind of come up with here is that we're using this much larger screen than most. So when we operate the Dragonfish, I let the fish do all of the work. It's doing all the flying. It's maintaining its AGL/MSL. It's maintaining how it needs to stay in the air. And all I'm doing is controlling the payload.
You're just guiding it as it is there. And it's really just a little bit step farther from your traditional multi-rotor type configuration. This is a little more hands-off, if you would say.
And also dual operator idea.
Right.
So you don't need an operator. It is the operator to fly it. You still need to be a pilot. But these aren't really traditionally used to fly it. Only for emergencies do we use the sticks.
It's not a pull-up type thing.
No,
it's doing its own thing.
And everybody that is usually used to that wants to be able to control it and fly it. So we have a huge screen here in order to interact with the payload. And that payload allows us to find a subject on the screen, figure out what it is. The aircraft directs itself to try to obtain that item on the screen that you're trying to find or you're trying to look at or maintain looking at, and the aircraft figures out how to keep it within that space, within that area. So we have a couple other functions, and happy to take you out the next time for a good old flight and show you some stuff.
One day when our weather settles down, if it ever does, while we're here in Utah at the moment anyway. But we definitely look forward to that, and we're definitely going to bring you that in another video.
Yeah.
But that's kind of overview of the standard model.
Yeah.
Let's take a step down just a little bit. to the light.
So we always have, the general idea is that if we're going to have something smaller, it's going to be less money. And yes, that was kind of the idea here, is to have something maybe not as expensive, still more than capable of doing exactly how we fly this. There is no difference in between the way they fly. They operate exactly the same.
They behave exactly
the same. If the payload is on a T3 here, it's going to do the same thing here. But what are we changing? The case is maybe not as big to transport it, and you have a little bit shorter wingspan. This also would be inclusive of having a little bit shorter flight time. So at max, you're running 75 minutes or so. Practical time, probably 55 to an hour on this aircraft. Now, I don't want to say that it doesn't, again, have its advantages to be a VTOL takeoff, but when you're looking at it against other possible products out there, you're almost like 40 to 45 minutes with a competitive drone. Even our own Evo or something like that, you can be up there. So if it really is trying to take advantage of the VTOL capability, the optics capability, the Light might be a good choice for you.
Right, yeah, exactly. And I mean, that's one of the big things about these is, as you touched on before, is kind of that autonomous might not be the perfect word for it, but the tracking the objects and that kind of stuff, the capability that these payloads have for detecting and tracking objects and stuff is just, it's one of the massive selling points.
In order for them to cruise, basically we are, all of the wingtips are all facing forward, but when they do actually rotate up and we take off vertically, then transition into forward flight, we're usually cruising around 42 to 45 miles per hour. Hitting downwind, upwind, those are also challenges for the VTOL aircraft, just to keep that standardized. But if you need to get somewhere in a hurry, they can do it pretty quick.
The thing is, cover a lot of ground.
They cover a lot of ground.
Covering a lot of ground is a massive way. And that's not to say of what's in the background here as far as transmission range, 18-mile transmission range, which is incredible. And again, that just lends that to, man, we can really cover a lot of space in a very short period of time and do it pretty dang efficiently.
Yeah.
Right.
Well, let's take a look at the Pro, because everybody wants a little bit of that. What is going on with the Pro? So I'll jump on this side. The Pro is significantly larger. Yes. It comes in a significantly larger case. This case is the case that we fly with the standard. Everything goes into that case. This case isn't much smaller than that case, but it's about the same size. But this case is definitely bigger. This is the version we have right now. There could be some changes in the cases later to optimize that, but we're talking a much larger airframe. Batteries are significantly larger, so even the battery area is bigger. Different. It's large. It's huge.
Well, the one thing that struck me, you're talking about large, is this guy right here.
Yeah.
I mean, and you lose that in the context, and that's part of why I'm glad we're here doing this, is that seeing it with somebody next to it, I mean, you could take product shots and scale these the same way. Well, whoa, gosh, those look very similar. They look almost the same.
There you go.
But it's a hefty payload.
Yeah. So, we talked about the payloads. We've got the L20T. We've got the T3 here. This is the L50T. The L50T in size comparison is absolutely huge.
Yeah, I mean, let's just do that here. And that's a question that people have a lot. It's whoa, can I put an L50T on this guy? And it's like, no,
negative Ghost Rider.
That's not going to work.
Yeah, 7 kilograms all up weight here. 15 kilograms for the one behind us, 7 kilograms here, and you're just like 5 here. So, I mean, that by itself is like 2.
Yeah, I was going to guess somewhere in that range.
Yeah, it's pretty heavy. But let's talk about the payload here.
Sure.
So, 50 times optical, that's why it's the 50T. Also up to 200 digital. What's really cool is the thermal camera here is a 1280 by 1024.
Resolution.
That would be 4 times the resolution that you have out of a 640.
Right. Most people here, they think double the space, but it's actually 4 times the surface area.
Yes, 4 times. So we've got 4 times the space. What this does with a fixed lens, though, this is a pretty large fixed lens. It's like 20 or 32 millimeters. But anyway, that does give some really crisp clarity for whatever you're looking at. Does it mean we can see much further? Not always. Not always the case. But when I'm pointing down and I can see much more detail than I can a little bit more with the selected lens here, it does help a lot.
Well, and it makes sense because, you know, these are not the aircraft, they don't hang around at 50 feet.
That's right.
These are higher altitude aircraft typically. They're pushing close to our traditional 400-foot ceiling. They're getting close to that. So having that option with that different lens configuration can make a heck of a lot of sense.
Yep. So that 50 times thermal camera, wide camera, just like on the other, and a laser rangefinder as well. So this is all very similar to what the L20T offers. But you know, a lot of people think with the 50 times optical and a bigger digital that somehow you're going to be able to read the logo on your shirt much better at a distance of 16,000 feet. That not quite. But
there's nuances to camera stuff. But that kind of leads to a thing you were mentioning before we started recording, is that payload's moving up. You mentioned the advantage of taking something like this payload and putting it over here.
That is correct. So we can't take this and put it on here. It's way too heavy. However, we can absolutely take the L20T and put it on here.
Right.
What we're looking at with this is a 3-hour flight time, perfect conditions, and you'll probably get practical of about maybe 2 hours and 10 minutes. So that's still pretty high.
Right.
But with the L20T, you can get closer to that full 3 hours, because it's a much lighter payload.
Every ounce degrades performance.
Oh, absolutely.
Right, especially when you're talking about aircraft. So, being that capability, extending that range, and not a slouch of a payload is very powerful.
It's very negligible when you put stickers and paint and all this other stuff. But when you add all these things, even just gram by gram by gram does change the performance, and just doing that alone is a huge change.
It's a hefty boy. In fact,
it's a hefty
boy.
To you. Kind of expensive, but
yes, I really don't want to drop it. So, but as far as any of these go, I mean, obviously, use case wise, where do you kind of see every individual thing fit?
Well, so the hardest part about trying to sell a Dragonfish is cost, right? It's more expensive than any of the other traditional drones that we sell or even other competitors sell in a quad style design. One thing is that because of the cost, what you're looking at is more of a low batch manufacturing, thing. We don't have thousands upon hundreds of thousands of them out there. Like I said, I mentioned we have 30, 30 in the United States operating. So that cost does kind of come into that play because it's not a mass manufactured product.
There's not lines and lines of these things.
No, we're making them kind of as we need, and as well kind of pushing that idea. So with the cost though, when you incorporate this into your drone fleet, and it is an overwatch aircraft. This isn't anything that you're going to use. It can hover and hold like a normal drone. In fact, the standard can fly like that for about 24 minutes, 24 to 26 minutes, just holding a hover. But that's not taking advantage of that flight time, right?
Right.
But you can hold in a hover if you wanted to, and so if you were to look at it more like I said, a forward flight. Always aircraft, overwatch, situational awareness, other drones looking in windows if that's the case, doing work and doing large search patterns. This is what you would be using it for. Long flight time, way more than having to switch out your different drones over and over time, or even your drones, piggybacking on top of each other. So there's definitely some advantages of being able to fly this for an extended amount of time over the traditional drone.
Definitely. So, and really, kind of the last thing we want to touch on for this is because you're talking limited number of these out in the thing. That's the thing about RMUS, kind of selfishly for us, is that we are one of those.
Yes.
Authorized.
So,
let's talk a little bit about that.
Let's talk about that. So, when we are talking about an expensive aircraft, one of the reason why I came to Autel was to produce a training program that kind of made sense. You and I have worked together a lot on producing training for the industry based around whatever equipment is out there. We need to know our stuff. We need to understand it. Well, not a lot of manufacturers make training that you, now RMUS, not me anymore, follow. And here I have created as a standard for Dragonfish training at least, a certification that is required by Autel Robotics. With that being said, I only chose a handful of people to be able to be authorized, not just to sell it, but also to teach it. and ArmUS is one of them. So that
not just anybody is selling these.
No, we do have other dealers that have it available, so of course that's the case. But the fact is that we do have a program. Autel has got a regiment on how we're going to.
It's standardized.
We have to standardize it to every person. Every dealer should receive the same training, the same certification. And I was really happy to find out that ArmUS wanted to sell basically my Dragonfish.
Right.
Yeah. So really happy to get that to your customer base, and I know already you guys have done a great job moving a lot of equipment to the current customers you have.
And that's what we always do. What we always want to do is be able to support the stuff that we put out, especially a type of aircraft that's like this.
Yes,
for sure. So definitely, again, once the weather turns, we're going to get an opportunity. We'll go out in the field in a later video to be able to get these up in the air and kind of show them in action, if you will. We're definitely looking forward to that, and nature will tell us when that's going to be the case. Hopefully it's sooner than later. So definitely look forward to that. And really, thanks again for letting us join you here and kind of having a chat about this, taking time out of your schedule so we could do that. And of course, as always, make sure you stay subscribed to the channel. That's going to be the easiest way to be aware of when we actually make it out into the field and do those flight tests. So thanks again for joining us, and we'll see you on the next one.